Good morning, everybody. Last stats class. Fortunately, we have another semester for most of you, so won't miss it too much. A few weeks without. What we're going to do today is we'll review for the final exam, which, as you guys know, is Wednesday, 3:30 p.m. Registrar hasn't got back to me, so just come to this room, okay? Just SchwabRoom202, come to this room, and then we'll work it out from there, all right? I'll find a place for sure, but come to this room. We talked about the format of the exam last class, right? And you guys kind of set the format with, well, I said it, you helped, you gave some input. And then at 11 o'clock, we went over that as well. But what I'd like to do today is now that we have a format, we have the material that's going to be covered, I'd like to kind of spend our time together taking any questions and also reviewing for the exam. So the other assessment we have is that take-home that's due Sunday night, right? There's those two normal curve, norm disk, norm inverse problems. It's only worth 10 points, but it's due Sunday night, so please get that done. Let's go to Blackboard and go under sample exams, and at the very top, I kind of put together a document called the Stat 301 Final Comprehensive Exam Review Document, chapters 1 through 7.2. So I have a lot of information on here. Let's take a look at that information. So first, let's start at chapters, sections included. Which is kind of the second thing down here. Chapter 1, section 1 only. That was a lot of just information. Talked about descriptive statistics, inferential statistics, what a sample is, what a parameter is, what a population is. You guys remember those terms? So just multiple choice from chapter 1. Chapter 2, we covered all of chapter 2, and that was all on graphical descriptive statistics. So one of the important components there was the types of data. You remember types of data like nominal, ordinal, interval, and then we determined what based on the data, what kind of graph we're going to create. You guys recall that was in chapter 2. So that's important there. You also have, I told you you're going to have a bar graph to create on Excel as part of this assessment. Chapter 3 was numerical descriptive techniques like measures of central locations, measures of variability, measures of relative standing, and also measures of linear relationship. You also have to do an Excel problem on that, where you'll figure out numerical descriptive statistics, right? That was one of the potential Excel problems. Chapter 4 was data collection and sampling. There were really no problems in there. That was about data collection and sampling. That was about the way we gather data. Remember, we talked about observational versus experimental, simple random sample. We talked about sampling error versus non-sampling error and the types of errors. Those were good multiple choice questions. Chapter 5 was probability. We kind of just got tested on that not so long ago, so that one should be fairly fresh in your mind. Chapter 6 was discrete probability distributions, and we talked about expected value, talked about binomial, we also talked about Poisson. And then chapter 7 was continuous, and that's kind of where we stopped. We talked about the uniform one, and I'm probably not going to cover anything on the uniform one. It was just kind of an intro thing, but the one that's most important in chapter 7 is the normal curve, right? We have some 5 multiple choice on the normal curve, and also a problem, a manual problem on the normal curve, plus you have that Excel take-home on the normal curve due Sunday, right? So that's kind of the new thing. So as far as the exam format, it is 2 of 3 Excel problems at 10 points each. So you're going to do those first, right? So you'll come in, I'll make it available on Excel. It'll really just be one data set with like 3 parts, like A, B, C, and I'll ask you to do 2 of the 3, like A and C, B and A, whatever the combinations are, but you'll do 2 of 3.
So you're asking, not us choosing.
No, you'll have A, B, and C. You choose 2 of the 3, right? So So A would be maybe create a bar chart, okay, of this data set, right? B would be, do numerical descriptive statistics of this data set or field in this data set. And 3 would be create a pivot table, with a slicer. We have some examples out there. So you'll do 2 of those 3, put them in one Word document and submit it online. Does that make sense? So it'll be one problem with 3 parts. You'll do 2 of the 3 parts. One data set. Yes, no? Okay. There will be 35 multiple choice questions. 30 of them will be ones that you've seen before. They'll be from one of the first 3 exams. So they'll be review ones, cumulative ones, if you will. 5 of them will be brand new. They'll be on the normal curve, okay? Continuous probability and normal curve. And then you will do 2 or 3 annual problems. Actually 2, I don't know why I do 2 of 3, I guess that should be. You'll do 1 probability, where you'll either do like a joint probability table. If you guys remember that, we did like the watch the videos and high pass, you remember that one? Or a joint probability or table where, marginal and conditional probability. And definitely a normal curve question like we've been doing, right? So definitely one of those. And that'll be worth 20 points. So we add those all up, we get 110 points. The exam will be held this day. It'll be held in a place to be determined. I'll email you guys as well as soon as I find out, okay? So check your email. Exam will be open book and open notes, right? So as far as that goes, you can bring in whatever you like, just no communication, right? No communication with others. You can watch the lecture captures if you like, if that would help you. I think that'd be a tough thing to kind of do. You can bring in poems if you like, haikus, it doesn't matter what, motivational things, whatever you like, you can bring in. Students will complete Excel component first, and then we'll move on to multiple choice and manual problems next. The study material, the things you can study from. Obviously the text. We center this course around the text. I told you, or at least earlier in the class, I told you about, I think one of the things about this text, that it's cheap, which is nice. We use it for Stat 301 and 302, which is even nicer. And these study cards, these like cardboard study cards in the back, you guys, what I'm talking about? That's not cardboard, what do you call that? Like a card stock. I think they're pretty good. They're very useful. They're very useful for studying. So check those out because they're doing a nice job of abbreviating a chapter into a page. Course PowerPoints, obviously, and then course lecture captures. I take a lot of time to capture the lectures. So hopefully, if there's something you can't remember, you can bring those up. Obviously, exam 1 through 3 sample exams available on Blackboard, right? Every exam, I provided a sample exam. We reviewed that sample exam. You took the actual exam. So because this is cumulative, those are good learning resources as well, and we're going to use those today. So I thought what I'd do is we'll go back to this stuff, but because we never had a test already on the normal curve, and I said there's going to be some new stuff that you've never seen before on the normal curve, right? Because we didn't really have a test on that. I kind of, instead of creating a full sample exam for the final, I created a little mini one of just that new material, right? So there's going to be 5 multiple choice on the normal curve, and here's 3 examples of what that'll be like. So maybe you guys can help me do these right now. A smaller standard deviation of a normal distribution indicates that the distribution becomes what? So what would the answer be? So we decrease the standard deviation. So that means what? What does the curve, what happens to the curve? Very good, Kyle. If we increase the standard deviation, it becomes flatter and wider. If we increase the mean, it shifts to the right. If we decrease the mean, it shifts to the left. Yes? What 2 things control the shape of the normal curve? The yin and the yang, the mean and the median. The median and the standard deviation, the mean and the standard deviation. What do you think for this one? 2 things that control the shape of the normal curve. 2 things and 2 things only. D, the mean and the standard deviation. I also told you I'd give you some Z lookups, right? So you'll have to do some Z lookups in the multiple choice. Given that z is a standard normal random variable, what is the probability z is between negative 1.0 and positive 1.5? So if we draw this, it's that area. So how do we do that when we have a between situation? When we have a between situation, what do? Explain to me what we do there, Evan. Very good. So when we have a between situation, we look up the first one, we get the whole cumulative probability of 1.5 and down. So 1.5 and down would give me, from here down, is 0.9332, right? You guys can look that up in the table. 1.5, 0, 0.99332. Negative 1.0 is 0.1587. That's this part. So this is more than we want. We want to cut off this part. Mathematical operation for cutoff is subtract. So I think we get 0.7745, which is letter A. Evan? No, you need to memorize that. No, we'll get that. That joke never gets old. I use it every damn year. All right, so you guys could do those, yes? How about the normal curve problem? And actually, only A, B, and C are the three you can do because we didn't do D and E, so I shouldn't have put those on there. But why don't we take a shot at that? Since it's new material, let's spend the most time on that first. I'll just do it. You guys can do it with me. Hope you guys can't see it. So it says the recent average starting salary for new college graduates. So you'll definitely have a manual problem like this. In MIS is 40,000. Assume salaries are normally distributed with a standard deviation of 5,000. Actually, it's probably higher than that now, but this is just to make it easy. Okay, so this is our deal. This is our normal curve. 40,000. Or standard deviation of 5,000. Let's see what we're looking for. Part A says, hey, what's the probability? It's between 35,000 and 47.5. Part B says greater than 30,000. And part C says less than 45,000. All right, so let's take a look at that. In all these cases, let's do C first. That'll be the easiest, so we'll do C first. It says, what's the probability X is less than 45,000? Well, if we go up here, 45,000 is here, and we want less than 45,000, so that shape is the probability we're looking for, right? Less than 45,000. The area of that shape is what we're looking for. How do I find that area? What do I need to do, though? What do I need to do with that X value? Because I don't have a nice formula for that shape, so what do I need to do? Convert that X value to what? The Z value, which is the standard normal curve, using this formula. Z is equal to X minus the mean divided by the standard deviation. Okay, Z is equal to X minus the mean divided by the standard deviation. So if I do that, I get the probability that Z is less than 45,000 minus 40,000 divided by 5,000. I get the probability that Z is less than 1.0. Okay, so on the standard normal curve, now we're down to a z lookup. Because it's less than, all I have to do is what? Because it's less than, all I have to do is look it up in my table. I look up in 1.0, and I get 0.8413. So there's like an 84% chance that they make less than $45,000. You guys all can do that. You understand the lookup process. You understand converting it to a z-value, yes? Bless you, Daniel. Let's do part B then. It says, hey, how about greater than 30,000? Well, 30,000 is here. What part of the curve is greater than 30,000? Well, let's convert that to a z-value. 30,000 minus 40,000 divided by 5,000 gives me the probability that z is greater than negative 2.0. Okay, if I look up negative 2.0, I get 0.0228. That doesn't make sense though, right? That's not the answer because that always gives me area to the left, 0.0228. And I want area to the right, so how do I get area to the right? 1 minus 0.0228 gives me 0.9772. So there's a 97% chance that they make more than 30,000. You guys with me? A says, hey, what's the odds that it's between 47.5 and 35,000? Well, if I convert that to a z-value, or both of those to a z-value, I get z is between negative 1.0 and positive 1.5. Which is what we did earlier, right? So it's a between deal. So I look up, actually we did this for the multiple choice, which is kind of ironic. If I look up 1.5 and down, I get 0.9332. If I look up negative 1.0 and down, I get 0.1587. If I subtract the two, it gives me 77.45%. I didn't put one like this on here, but what if I asked you this? What if I asked you, hey, what's the probability that someone makes more than 90,000 to start? What do you think? Well, probability someone makes more than 90,000. Let's convert that to a z-value. Well, z is greater than, let's see, 90,000 minus 40,000 divided by 5,000. Gives me the probability z is greater than 10.0. So you may get one like this, and then students tend to panic because they don't see 10.0 in the table, right? You can't look up 10.0 in the table. It only goes up to 3.89, I think, or something like that, or negative 3.89. So why is that? What's the answer to this? Rachel? Yeah, remember the normal curve goes up like 99.7% of all observations are within 3 standard deviations of the mean. So we're going out 10 standard deviations here. What's greater than 10 standard deviations? Virtually nothing, right? So virtually 0 is the correct answer to this. Does that make sense? But what if it were the opposite? What if it was probably x is less than 90,000? So we get probably z is less than 10.0. So what's the odds that they make less than 90,000? Obviously, what would that, 10.0 is here. How much of the curve is to the left of it? Damn near all of it, virtually 100%. Does that make sense? Yes? So just, if you get a number that's not on the table, don't come up here on the exam and say, Dr. Miko, just trust yourself. Think about it, right? And it makes sense. If the average salary is 40,000 and standard deviation is 5, hey, what's the odds someone makes more than 90? Virtually 0, right? That's an outlier. That's an extreme outlier. Yes. What's the odds that someone makes less than 90? Well, almost all of them, right? Virtually all. Makes sense, doesn't it? Think about what you're finding. The math just, don't get lost in the math, I guess is what I want to say. All right, so that is like the new stuff. Does that make sense? No, we're not doing D&E because we didn't learn how to do that. We learned how to do that with Excel, Stefan, but I didn't show you how to do that manually. I'm not going to. So you'll never need to know that for assessment purposes. You can do it with Excel, though. All right, so how would you guys like to do this? We got what, we have like 50 minutes together. Yeah. How do we make use of our limited time together, Mr. Boyd? Hang out? I would enjoy that, I'm sure. You would enjoy it as well. I'm fun to hang out with. But what should we do, Stefan? Huh? Go to Torbian? Well, early for Torbian. It's 9:53. You look at what? Well, that's that. Game for bonus. Man.
That's a good idea. What about we do, like, you said?
Go ahead, Stefan. I think you're thinking, well, I'm thinking now. Huh? What?
Or does Excel thing? You said we can choose like two. What if we do three? Can we get Excel?
No. All right, so let's take a look. I think probably the best way to do this is to take a look at the sample exams from the beginning of class, right? So let's do that. Agreed?
Yes.
Am I the only one that thought that might have been a good idea? No?
Yep.
All right.
Here we go. Oh, there it is.
Okay, so let's go to Blackboard, and let's look at sample exam 1, Excel and multiple choice portion, okay? So I'm going to bring that up. Looks like I even prepared a little review video that you can watch. I'm a pretty good teacher, all right. Pretty good, huh? So let's look at the Excel portion first, okay? So this is sample cells, data 500 transactions. Okay, so you could possibly, this is probably a good one, right? This is a good one because it contains, it's kind of a pivot table one. So determines the relationship between container and ship mode. Please perform a crosstab on these two fields. Please place container on the rows and ship mode on the columns. Instead of counts, I want to use percentage of row. Create a bar chart to represent the pivot table you created in step 1. Include all these items in one Word document. So there's a video reviewing that, so you can watch that video, or I could do it again if you're totally lost. But that could be a good question. That would be actually 2 of the 3 things, right? A pivot table and a bar chart, right? So that's probably a good one to look at. Yes? Let's look at the multiple choice portion. Let's go back there and see how. So the first couple here, if we look at this, probably number 1 is probably a good one to look at. A politician is running for the office of governor of a state with 3 million registered voters, commissions a survey. In the survey, 53.6% of the 5,000 registered voters interviewed say they plan to vote for him. The population of interest is what? What would the answer to this one be? This one's good because we can do a couple things with it. What's the population? Jonathan?
3 million.
You're right, Jonathan. What would 5,000 be, Jonathan?
Sample.
And what is 53.6%? Is that a statistic or a parameter? Because it goes with the sample, Jonathan, and it is a
Statistic.
very good. If at the beginning of this I said, I think 60% of the population is going to vote for him, that 60% would be a very good. So that's That's a lot of chapter 1 in a problem, right? Which of the following is not the goal of descriptive statistics? Well, descriptive stats summarizes, displays aspects, reports numerical findings, estimating characteristics of the population. That is a goal of inferential statistics, right? Confidence level measures. Well, that's just a definition. If you get that one, that should be easy because you have open book. The best type of chart for comparing two sets of nominal data. Two sets of nominal data. What do we use when we compared? Remember, nominal data was like categorical data. We used what? A multiple bar chart for that purpose. The number of cars in a given parking lot, example, what type of data? So there's 80 down here, 300 in JFK, 20 over in De Gaulle. Those are numbers, so what type of data is real numbers? What? Interval, right, very good. If I'm talking about marital status, like married, single, widowed, divorced, gender, male, female, religion, what is that? Nominal, very good. If there's a ranking to it, however, like that's ordinal, very good. So there'll be a couple on that, if you guys recall those types of data. Probably not do anything with that. No, I don't think. Salaries, what type of data? Anytime it's money, it's interval. Large, medium, small. Ordinal, very good. What is the function key to make a cell reference absolute in Excel? Remember the dollar signs? F4, very good. Pivot tables. Okay. So sample test 1, that was on chapters 1 and 2. So the types of data are very important. The graphs and what they're used for. If I've talked, how do I display time series data? What was the chart I used for time series data? Line chart, very good. Comparing two sets of interval data. Like remember my ice cream sales and temperature. What do we use for that? What was the chart we used for the chart we used for that? Scatter diagram. Okay, so chapters 1 and 2. Any questions on that? Okay, let's look at sample exam 2, Excel and multiple choice. So let's look at this. So in class Excel exam 2, I'm not going to make you know anything about, not that I don't want you to know, but you don't have to worry about percentiles. You don't have to worry about correlations for this exam. So, excuse me. And you don't have to know anything about geometric means. So really, from the Excel portion here, this is really the only one that you could do. You'd have something like this. So I'd give you data and say, calculate the arithmetic mean, median, mode, range, standard deviation. Considering these grades follow a bell-shaped distribution, interpret the results using the empirical. So those are the 3 possible Excel things to do, right? One problem, we'll do 2 of the 3 things. There'll be a pivot table, there'll be a numerical thing. You guys will probably be all over this one. It's easy to do. And there'll be a bar chart, okay? Yes? All right. Let's look at the multiple choice then here for this sample exam 2. Oh, I like that one. Which of the following is not like the other? You remember we did a couple of these. Is that song in your head? It's in my head. Which of the following? So the first 3 are measures of variability, range, variance, and standard deviation. The last one, mean, is a measure of central location. So D is not like the others. Which measure of central location is used for rates of change? Remember, like percentages, what do we have to use, Daniel? Very good, the geometric mean. A perfect straight line sloping downward, y decreases as x increases, will produce a coefficient correlation equal to -1. Very good. What's the name of given to extreme observations that are 1.5 times the IQR beyond the first or third quartiles? What do we call those? Outliers. Very good. Another name for the second quartile. It's also known as the median. It's also known as the 50th percentile. We talked about non-sampling errors, right? All of these are examples of non-sampling errors. What's the big difference between non-sampling error and sampling error? Sampling error can be reduced by doing what? How can we reduce sampling error?
Increasing your size.
Increase the sample size, reduces sampling error. Very good. This is the cost of slinkies. Which value represents fixed cost? Which value represents variable cost? So our cost line is y is equal to 9,500 plus 1.5x. Which part is variable? Which part is fixed? Fixed cost never goes away. Which part of that never goes away? Even if x is 0, we still have 9,500. Every additional slinky produced costs us $1.50, so that's the variable cost. Does that make sense? Yes, yes. Karen and Armando both have a GPA of 3.35. However, Karen has a standard deviation that's higher than Armando. So who's more consistent? Armando, because smaller standard deviation means, more compact. Remember the empirical rule. Empirical rule said mean one standard deviation this way, one standard deviation this way, 68%. Two standard deviations, 95. 3, 99.7. We have a normal curve of mean of 100, standard deviation of 10. We're going out 30 and 30, 70 to 130. So we're going out 3 standard deviations. So according to the empirical rule, 99.7. Very good. Okay. None of these problems will be on the exam. Okay. None of these types of problems will be on the exam. Sample exam 3 with answers. Okay. So this was the probability guy one. This is the probability one. We just did not so long ago. Seems like not so long ago. So we talk about probability. We talk about a random experiment. And we put in the outcomes in something called a sample space. In that sample space, there are events and simple events. So when I roll the 6-sided die, the act of rolling a 3 is a simple event, right? A simple event. Conditional probability, probability of A given B, we join the two, divided by the probability of the second, which was 80%. This was using the addition rule to come up with that probability. The collection of all possible outcomes of experiment is called a sample space for sure. Independent events means the probability of A given B is the same as the probability of A. Like just because we know B didn't change the probability of A, and that's what we have here. Because the probability of A is 45%, probability of A given B is also 45% independent events. Let's see. Oh, remember there were 3 methods we used to estimate probability. If it was based on, like I have 100 ping pong balls in a bucket, 1 black, 99 white, what's the odds I pull up that black one? Is 1 out of 100. What method is that? God bless you, Sue. It's called classical or mathematical. If I look back historically and say, 95% of students have passed my class over the last 14 years, look back historically, what method is that? Relative frequency. If I say based on me knowing you and knowing how good of a student you are, I'm going to say there's a 99.9% chance you graduate from college in 4 years. That is subjective approach, right? Does this make sense? So those are good multiple choice questions. Okay, this was, what's the difference between continuous and discrete random variables? So time is what? Continuous, right? The number of children you have is discrete, right? If it's countable, it's discrete. If it's uncountable, it's continuous. This is a discrete probability distribution table that we had to interpret. That was pretty easy, I thought. All right, and then so of these, okay, you're going to get a number 2 like one, or a number 3 like one. Okay, so number 2 is a joint probability table, and number 3 is a probability tree. So you're going to do either a 2 or a 3 for the exam. Looks like we had a quiz, Excel quiz at some point too. That would also, that's a good example for, that was creating a bar chart, so that's a good example of the Excel problem as well. So I don't know, that was kind of a whirlwind, wasn't it? It was kind of a quick overview. But what do you feel? I can't read your emotions, your thoughts. All alone. What do you think, Jeremy? You think we're cool? All right.
Yeah, I agree. We've seen all this stuff 4 times, we can go.
I want you, like I was looking at the grades, and the grades are okay, but I think I'd like to see them, overall, there's something, I look for a good, at the end I'd like to see the grades go up a little bit, right? So. No. See, here's how, here's my teaching philosophy. I like to look at myself like a coach, right? And so your coach can't say like, all right, so I set the, it's kind of different. Like I set the bar and I try to coach you to get over that bar, right? So if I set the bar low, that doesn't make me feel good, doesn't make you feel good, right? So I set the bar and then I try to coach you to get over it. Like, just be given something. You got to earn something. Don't you feel better when you earn something, Jermaine?
Most of the time.
What do you mean most of the time?
Like if somebody gives me something that sometimes I wouldn't. Like if you boosted my grade, I feel just as good.
No. I wouldn't have. I'd be like, well, I'm crazy though, so. I mean,
I just earn it next time. Like next time I'm in your class, you just make me work a little harder.
there's never a next time though. There's only that time. You know what I mean? There's never, you and I, we're going to live lives after this, right? After our little experience. This is the only time we're going to be together at Staff 301. So this is it.
I guess you're right.
Yeah, so, if you schedule like, who's at Faith University and you beat them bad, you're like, you feel good about yourself?
No.
You guys feel good after beating Faith?
No, I felt worse. Go right on the highlight.
Some people did? Yeah.
I felt
You felt good?
No, that's what it was. That is what that
You guys beat Penn State, right? You felt good about that, right? Yeah. You felt like you earned something, didn't you? You go over and beat Mount, you don't care, right? You don't feel much. What other questions? How else can I help you? Is it about you guys putting in the time? Is that what it's about now? That's good interpersonal skills. That's good.
We have more riddles.
More riddles? I'll give you a couple.
Now that I know it's actually riddle and not like trying to do something.
I'll give you a
It's a school thing that doesn't work.
Maybe Tuesday night. Our exam's Wednesday, right? What, it was 3 o'clock?
3:30.
3:30. Well, what I could do if you guys want, we could do like a study session right before if you want.
Yeah.
2 o'clock? Well, I'm only having it if you can come. 2 o'clock.
Whatever.
Yeah, somewhere. I mean, it's good like just in time. You know what I mean?
Yeah.
Or we could do it Tuesday night.
No.
No.
No. All right.
I'd
Well,
rather do it too, that way we study for Tuesday, and then the stuff that we are having trouble with.
yeah. Then you know your gaps, right?
Yeah.
Because right now you may not know your gaps. You know. All right. I'll email you that with the location of the final, location of the study. Hopefully, I'll get 106 for all that. We'll just go down there and. All right. I'll see you. I'm also around, so if you have specific questions, come and see me. I'm in my office. I got a little Christmas tree now. Come see my tree.
Is it a real one or a fake one?
It's fake. You can see it on the mall. It's a real little tree. You can see it? You saw it?
I will literally never.